Alright, example 16 is looking at the area of the region in the diagram. So the area of the region between the x-axis, the line y equals x plus 1, the lines x equals 2 and x equals 1. We're then asked to check the answer by working out the area of the trapezium. So that's the yellow trapezium that exists there. Part B is then to find the area under the line, y equals x plus 1, so same line, but we're now looking at being between the lines of x equals -4 and x equals -2. So I'd expect that when we go through and do this, we're probably going to get out some negative regions or a negative area, which we'll need to deal with. Alright, part A. So part A is finding the integral or the definite integral between 2 and 4 of x plus 1 dx. So I know it's 2 and 4 because I'm looking at the lines x equals 2 and x equals 4, so 2 to 4. And then the function that I have is x plus 1. So this is the setup. From here on in, it's just actually a solve of this. So there's not really much to do with it. It's just solve it pretty much. So we need to do the integrals. So the integral of that is a half x squared plus x, and we're still interested between 4 and 2. Substituting in 4, we'll get a half 4 squared plus 4, and then we're going to minus a half 2 squared plus 2. Taking that a step further, we should get 8 plus 4 minus 2 plus 2, so leaving us with 12 minus 4, or 8 units squared. We do need to check this, so we're going to check it using the area of the trapezium formula, so a half a plus b multiplied by the height. In this case, a is 3, b is 5, and the height is 2. When I go through and do this, I'll get a half times 8 times 2, which is just 8, so that's accurate, or we've checked our area region using the trapezium formula to get out 8 again. Part B is the area under the curve of y equals x plus 1. So I'm just going to draw a sketch. It really is just a sketch. And I've got a line -4 and -2, so -4 here, -2 here. My function y equals x plus 1 means that for this portion, I am negative. I'm below the x-axis. So when I do my integral, I'm just going to need to take into account the fact that it is negative. And I can do that two ways. I can either put a negative out the front of my integral, or I can switch my limits and go from -2 to -4 instead of -4 to -2. Two options will get the same result either way. So setting this up. So the area is going to be equal to the integral between -4 and -2 x plus 1 dx, with a negative out the front of that in order to take into account the negative. So I'm going to run that negative all the way through. So do my integral half x squared plus x, and then running it between -2 and -4. Substitute in my values, noting that when I actually do these, raising something to the power of 2 means that my negative is going to become positive. So I will get out here a negative 2 plus -2, so 2 minus 2, and then minus 8 minus 4. Simplifying this out, I'll get out -4, but then that negative out the front makes it a positive.